Hello everyone, welcome you to the next video of this well test interpretation course. And in this video what I'm going to do is basically discuss regarding the types of well tests. Now let me recall some important stuff that I told you in my last video. The first point is that in well testing we provide input and we observe the output. Now what is meant here is that basically through an input what we are doing is that we are creating a disturbance in the reservoir system, and that disturbance is what the system translates into the pressure response, and the pressure response is what we are observing and what we are noting down. So creating the disturbance is under our control, and the pressure response is directly related to the type of input we provided as well as the system properties. And in well testing what happens is that the input that we provide is in the form of an alteration in rates. And what is meant by an alteration in rates is that we can either control the production rate and or we can control the injection rates if applicable. Now the point that I would like to emphasize is that input is the parameter that is under our control, whereas output is dependent upon system and input. Input, that is an alteration in the flow rate, is something that we are controlling, we are generating, and pressure response is merely a reflection of what we are providing as an input to the system, and the system properties that are translating that input to a pressure response. So this is something that you must be knowing quite well. Now the types of well test: there is drawdown test, build-up test, injection test, fall-off test, drill stem test, and interference test. And a drawdown test, what happens is that we start flowing a well that is initially shut in, static and stable. The flow rate is supposed to be constant. Let us see how this test is represented on the pressure versus elapsed time diagram and rate versus elapsed time diagram. Initially the well is shut in as mentioned by the definition of the test. When the well is shut in, the pressure is constant, and at this particular moment in time we decided that we have to flow the well, and the moment we start flowing the well, the pressure start declining. This is the input that we are providing, that we are actually changing the rate, the production rate that was initially 0, and what we are doing is that we are increasing its value to some suitable value. And this input basically this was the input, and this is basically reflected as a decline in pressure, and this is the pressure response. On the rate versus elapsed time diagram, what happens is that initially the well was shut in, so there is no rate, the rate is 0, and at this particular time we provided the input that was we altered the production rate, and the flow rate increases to a certain value and becomes constant, as this is an assumption of the test. Now advantages and disadvantages. This test is suitable for reservoir, knowing the reservoir limits. This is because it takes a long time to conduct this test, and in order to know the reservoir limits we need quite some time. And as the time is long, what happens is that the fluctuations in the flow rate is minimized due to the huge amount of data that we have. And more importantly, all that is that the traditional analysis methods that we are using in our well test interpretation are mostly developed for drawdown tests. The disadvantages of this test is that it is difficult to flow a well at a constant rate. So if the well is not flowing at a constant rate, there will be some discrepancies in our calculations that we do on an assumption that the rate is constant. And in the second disadvantage of this test is that well conditions may not be static or stable. And how I can say this is that if the well is newly drilled or is not shut in for a longer period of time, so we may achieve this kind of situation that the well conditions are not static or stable. The next test is the build-up test. In the build-up test, what happens is that a well that is flowing initially at a constant rate is shut in, and the downhole pressure is measured as the pressure builds up. The input here is basically an alteration in the production rate. In this case, we drop the production rate to zero, and the pressure response is basically the pressure buildup. So the value is dependent upon the type of input as well as the system properties. On the pressure versus elapsed time diagram, the first half of the curve basically represents the flowing period. The pressure is declining, and at this particular moment, that is the pointed area in the curve, what happens is that we provide the input, that is basically we drop the rate to zero, this thus creating a disturbance, and the the pressure start rising. Now on the rate versus elapsed time diagram, what happens is that initially initially the well was not flowing, so the flow rate as the well was flowing, so what happens is that the rate was constant as we assumed, and the moment we provide the input, the pressure drops, and the rate drops because the well is shut in now. This kind of a situation happens on the rate versus time diagram. The advantages and disadvantages are the first one is that constant flow rate condition is easily achieved as the flow rate is zero. This is something that we need because we are using the same or similar analysis techniques that we use for drawdown testing, and the assumptions in all those techniques is that there is constant flow rate condition. So this is a big advantage of the build-up test. The disadvantage of the build-up test are that it is difficult to achieve constant rate production prior to shut-in, and there is a production loss while the well is shut in. Thus, our company lose money whenever we conduct a production build-up test. In an injection test, what happens is that what we do basically, we start injecting into an injection well that was initially shut in. Here the input that we are providing is in the form of change in the injection rates rather than the change in production rate as we do in the drawdown test. And this change in injection rate causes or translates into the rise in the reservoir pressure as we are basically injecting a fluid in the reservoir. On the diagrams, initially the reservoir is at initial pressure, and at this particular moment we are providing the input, that is we started to inject and the pressure starts increasing. On the QT diagram, here at this particular moment the injection rate was minimum and started to increase as basically as because it is constant because we are actually injecting and it is much under our control rather than the production rate. In the advantages and disadvantages are is the first of all there is that is injection rates are easier to control than the production rates, and this means is that we have a much better control over our input. So the disadvantage of this test is that we have to face complicated analysis if there are multi-flow effects. And what happens is that these multi-flow effects arise when we inject a fluid that is not similar to the fluid that is present in our reservoir. For example, we inject water in our oil reservoir. So inevitably we have to face the multi-phase effects. So this will make our analysis quite difficult. In the fall off test, what happens is that we stop the injection and observe the pressure decline. So it is similar to the build-up test, but the input is basically the alteration in the injection rate, and in this particular case it is basically dropping the injection rate to 0. On the diagrams, this initial period shows injection period in which we are injecting a fluid in the well, and at the peak of the curve at that particular time we provide the input by stopping the injection, and then the pressure starts declining. On the QT diagram, basically initially as the what we were doing was injecting the fluid at a constant rate, and at that particular moment what we did was we stopped the injection, so now the injection rates become 0. Here injection rates are shown below 0 because we are injecting into the well rather than taking out of it, so we are basically equating it with a negative sign. You can understand it by comparing it with this idea. So the advantages and disadvantages, the first one is the same, is that injection rates are easier to control. And then another advantage that it has over a build-up test, or I can say its closest cousin, the build-up test, is that the production loss is small as compared to the build-up. So in build-up test, we shut in the well, therefore we do not have any production from it. Whereas in the fall off test, where we are stopping the injection, so we will observe a decline in our production, but we will not see a complete um, stop of our production. And the disadvantage is that multi-phase effects make the analysis difficult. In an interference test, what happens is that one well is produced or shut in, and the pressure response is measured at another well or wells. An interference test helps us to characterize the reservoir over a large scale rather than a single well test. Therefore, the bulk reservoir properties are easily um, found out by using interference testing rather than single well tests. And interference test is basically possible with any type of pressure disturbance that we can create, either by draw in the manner of drawdown, build up, injection, or fall off. In drill stem test, what happens is that this test is basically first of all carried over a newly drilled well with the rig is still in place, and we temporarily complete the well by the help of the tool, and we produce the well for a small period of time, and then we shut in, and then we again start producing, and this time for a longer period of time, and then we shut in again. And basically what we are doing is that we are checking the well's potential or well potential with the help of this test, as well as we are sampling fluids. So references basically in this video: Modern Well Test Analysis by Robert N. Horn of Stanford University. And in the next lecture what we would be discussing is that we would continue our discussion that we left in our first video, that was concerning the fundamentals of the well test. So thank you very much for your time.